everyone. So today we will be doing the benchmarking presentation. So these are my teammates.
So I'm Chun Ting.
I'm Heng Qiang.
And I'm Joshua.
I'm Wei Yao.
So for computer use, this is my computer A, which is a MSI Ting UF6312UC Intel Core of i7.
So computer B is my computer Quanta NL9E from Ilegia, and it is using the Intel Core i7-6700HQ.
And computer C is my laptop, which is Asus TUF Gaming F15 with Intel Core i5 11 Gen and 400H.
And computer D is the computer I'm using now, which is Lenovo 20QS QGS 07R00 using Intel Core i5 8365U.
So I'll be telling you the introduction of our project and our benchmarking presentation. So system specification alone aren't enough to determine a computer's actual performance. That's why we are carrying out this benchmarking process. Even devices with similar specs or similar specification may perform differently under real-world tasks like gaming, multitasking, or file transfer due to factors such as CPU generation, RAM type, disk speed, and system configuration. So why the benchmarking matters? Benchmarking actually helps to identify these differences by objectively testing the system performance, offering clearer and more reliable performance comparisons. So the aim of this project is to conduct a comprehensive benchmarking and performance analysis on 4 students' computer, which is 4 of us, and the focus area will be using free benchmarking tools and custom assembly code ASM to assess the CPU and disk performance. Second, measure the system behavior under different workload levels. And the third, lastly, is providing the practical insight for the computer selection and system optimization. So next.
For the objective of this project, we need to understand the concept and importance of CPU and storage benchmarking. The benchmarking tools that we use are CPU-Z, Bit-Bench6, Task Manager, Mini2, Partition Wizard, and these are to collect the system performance data. And next, we develop an assembly program for CPU stress testing through polynomial computation. We also simulate various workload scenarios which from either to high workload. And last, we analyze, interpret, and compare benchmarking results using chart and tables. For the scope among this project, we use our benchmarking tools, the custom assembly program for CPU stress test, workload simulation from either to high, and for the high workload, we use gaming and multitasking scenarios, and the last one, performance evaluation, which are CPU speed, disk read or write, memory usage, and real-time performance data collection.
Alright, so for the benchmark execution, we restart the computer first before starting the benchmarking process to ensure the accuracy and the consistency of the result. So in CPU-Z, we'll do the passive attack to get the detailed information about the CPU and the data for the CPU, motherboard, memory, and the SPD. And in Geekbench, we run benchmark and record the results on various tasks such as test processing, power conversion, and object detection. So in the window test manager, we will record the CPU performance at different type of workload, such as idle, low, medium, and high workload. And in Mini2 partition wizard, we will test on the two modes, which are the sequential and random mode, the reading and writing. And lastly, in the assembly code benchmarking, we'll test this type of loop to simulate different workload, which is 50, 100, 200, 500, 700, and 1000, and get the execution time. So we will pursue the CPU.
This is a chart for core speed comparison, and computer A excels in its core speed with 4389.26 megahertz than the other computer, while computer B having the worst core speed, which is 1596.88 megahertz. And these processor results indicate that computer A potentially having a best performance. Computer A have a much larger cache than other computers, which indicates higher chance to in cache hit, and computer B and D both lack in cache size, indicating less data can be stored in cache for retrieval purpose.
And move to Geekbench. Next slide. And for this, we will do the comparison core performance score. Then through this comparison, we can find that the computer A stand out as the top performance with the highest single core and multi-core scores, proving that it's the most with the most capable system for both multitasking and performance heavy application. So the core performance is influenced by more than the performance processor generation, the core count, chip count, and also the clock speed have a significant impact on system performance. Next slide. Then here is a result for the single core performance test. Then throughout this test, we can find out that the computer A performs exceptionally well in this performance where computer A could offers the best responsive and speed for everyday use and optimized for handling visual tasks. And computer B result shows it has slightly good in some features to be chosen for daily users. And computer C provides a moderate stable performance, but does not excel in high-load CPU tasks as computer A. So it is more suited for light to medium tasks. And last but not least, the computer D shows the weakest single core performance overall. So it is suitable for basic object detection and lighter imaging tasks. Then next, move to the multi-core performance test. And throughout this test, we can find out that the computer A consistently achieved in the highest score in all multi-core tasks. So making it a more capable system for multitasking, gaming, and heavy processing. Next, the computer B's results were lower than expected in several categories, but despite having a i7 processor. So this highlight the computer's generation alone isn't enough to ensure high performance. So without sufficient cost, tricks, and a well-balanced system. And computer C delivered stable, reliable performance in most categories, so making it a strong option for daily use, multitasking, and creative work. And last but not least, the computer D handle basic and moderate workloads well, but showing limitation in demanding tasks. So it's better suited for general office use and light application. Okay, now pass to the next person.
And for the task manager, we are going to show you about the 4 types of workload, which is the idle load, low load, middle load, and high load performance CPU. So based on the graph, we can see under the simulation task, computer A having the best CPU performance. So from the 0 and to high workload, computer A always have the lowest CPU utilization. So it's showing the best performance. So we can conclude that computer A has a superior hardware specification, likely have a faster CPU, better cooling, or more efficient computer architecture. And we are also curious about what will happen when the PC encounters an action workload. So we can observe that the CPU consumption and memory consumption goes high significantly when both games are running at the same time, as both games will compete for the CPU and RAM resources. We can also observe that some tasks in the task manager is queued if it's unused or unnecessary, and some tasks will be set to efficiency mode to limit the resource used by the process. So if the optimization strategy is absent, the computer might face the issues such as terrible lag or even crashes or freezes. So for the mini tools, now we'll present these parts.
So thank you, Yao Ting. So for mini tools partition wizard, there will be 2 test mode that we are used. The first one is the sequential stress test, and it's able to measure the speed and performance of the disk to continuously read large blocks of data in order or write large blocks of data in order. While the second test will be the random stress test, which is able to measure the speed and performance of disk to read small blocks of data from random location or write the small blocks of data to random location. So without further ado, let's see the result of each test. So this is the sequential test result, the sequential reading. So on the left side, you can see the line graph for the comparison for sequential reading. So for these key findings, computer A is effective in sequential reading with either very small or very big transfer size, computer B has a stable sequential reading and is suitable to read small blocks as well as the big blocks, but it might take some time. And computer C transfer rate for sequential reading is capped at 1 at the transfer rate, and computer D has better and faster transfer rate when the transfer size increases. So for the sequential writing, next slide. So for sequential writing, computer A might be having the cooling issues for transfer process from 4 KB to 8 KB, and its maximum transfer rate is expected to be the written one. And the computer B works better with bigger transfer size, and it has the best sequential writing out of all computers. The computer C is limited by its maximum transfer rate that causes only slight increase in the transfer size as transfer size goes from 8 KB to 16 KB, and computer D seems to reach the maximum transfer rate at 16 KB. And the next one will be the random result. So the random reading, computer A works better with bigger transfer size, although it takes time. And random reading for computer B is really fast under transfer size of 16 KB, and as the transfer size is bigger than 32 KB, the transfer rate might be slightly increased. So computer C perform a good random result for size of block smaller or equal to 16 KB. Computer D might work better at bigger transfer size than computer B. As you can see, the slope is like expected to be higher than that. And it will be especially when the transfer size is bigger than 32, computer D will show a better transfer result. So for random writing, computer A, C, and D have only slight increment as the transfer size go from 4 KB to 32 KB. And this indicates that they are kept with the maximum transfer size since the transfer size of 4 KB. So for random writing for computer B, it's getting faster and faster as the transfer size increases, and this might be due to the big free space of the computer B. Next, I will pass my teammate.
Okay, so now I will talk about assembly benchmark. So this is a chart, stack chart bar. So we can see the difference between each computer is negligible, while only computer D having a significant more total execution time. So computer B consistently performed the best among all the computers in different number of loops execution, showing it does work perfectly fine under various workload. This is a line chart generated also for each number of loops. So all computers demonstrate a nearly perfect linear scaling because the iteration doubles, the execution time also approximately doubles. This indicates there's no significant thermal throttling during the test and showing the code is efficient. And we also can see the computer D having slower clock speed, as we can see all the lines are almost overlapping except computer D. And for conclusion, we conclude that computer A consistently delivered the best overall performance across CPU and these benchmarks. And computer B showed mixed result, strong in assembly code execution and random-based access, but it underperformed in CPU Z, Geekbench, and multitasking scenarios, possibly due to the configuration or the hardware limitations. And computer C showed good results in this sequential and random access performance, making it a strong contender for storage-heavy tasks. And computer D performed acceptably for general usage but stronger under heavy workload. So it's better for the basic task and simple tasks. So for key findings, hardware specification alone do not guarantee consistent system performance, and real-world benchmarking under different workload levels offers more accurate, reliable performance insights. And effective benchmarking helps you to identify the right computer for specific needs, whether for gaming, office work, or multitasking. So the final remark, benchmarking is very essential for making informed hardware decisions, ensuring system optimization and achieving the best value for the performance in different computing scenarios. So for the reflection, this project provides us a golden opportunity for me to explore benchmarking in a fun and convenient way. This is not just for the sake of the project, and it is also important for me to compare and select the computer I wish to purchase in the future. I have successfully explored different benchmarking tools and various professional terms of computer benchmarking, which gives me the clear guideline on how to benchmark and as a result ourselves in future. I also gain insights that computer works completely differently under different workloads, so it's very important for me to organize the processor resources well while I'm using the computer to maximize the performance. Although this project definitely benefits me in understanding benchmark and the way to optimize my computer performance.
So now I will be sharing my reflection. So throughout this project, I got to know a few freewares that can be used to benchmark my computer, which is the 4 benchmark tools. By carrying out the benchmarking process, I knew more about the specification about my computer as well as the processing time and performance of my computer using single core and multi-cores. And this enhanced my knowledge regarding the parts of my computer, and I understand more on the structure, organization, and architecture of my computer. I would say that this project is fun-filling and yet meaningful, since I've gained a lot of new knowledges that is really useful throughout the 4 years of study in computer science. I also want to express my gratitude towards my beloved lecturer, Dr. Fuad, for giving us such an opportunity to explore more on benchmarking computers through this project. I'll pass to the next person.
So, I will share my reflection. Throughout this project, I have gained a much deeper understanding of how computer systems are evaluated beyond just their basic specification through my computer. When doing all the steps of benchmarking, I just realized that how my computer performance, memory performance, and also disk performance under different workloads. Apart from that, through the Geekbench 6 application, I got to know the detailed information about my computer with testing to single core performance and multi-core performance. How far to test that how fast my computer will process each task in the test. So overall, I really enjoy doing this project and it's beneficial to me to give different insights into the computer science field.
Through this project, I have the chance to explore various benchmarking tools and gain deeper insights into how different components of a computer contribute to overall performance. By using tools like CPU, Z, Geekbench, and any tools partition reason, I was able to learn about the actual capabilities of my computer beyond just the listed specifications, and I found it interesting to see how different workload affect the CPU, memory, and disk differently. The assembly benchmarking was also helpful in understanding how raw performance is measured at a low level. Overall, this project was both informative and enjoyable, and it helped me apply what I have learned in class to real-world computer performance analysis. And I now feel more confident in evaluating systems and make informed hardware choices in the future.
All right, so that's all for our project presentation, and thank you very much.